want to define in C and Java, you will use curly braces to define the block. And you will write some set of lines inside the curly braces that becomes a block. So here in Python, we are not going to use these curly braces and all. The block itself is going to be defined with space itself. It is defined with a space. So space is used to define the block. Space is used to define the block. So I'll let you know how this indentation works further. And coming to the variable. In general, what is variable? Variable is a name given to a value that is stored in the computer memory. For example, here the value 6 is going to be stored in the variable x. So for the value 6, I am giving the name x. This value 6 will be stored in the computer memory. So the variable is nothing but it is the name given to a value. The value here is 6 and the name given to it is x. And this value will be stored in the computer memory. Then how to create the variable? The moment when you assign some value to a variable, variable is going to be created. This is how a variable can be created in Python. Similarly, when you assign some value to a variable, variable will be created. You can also assign multiple values to multiple variables at a time. For example, look at this statement. Here we have 3 variables. All 3 variables are assigned 3 values at a time. This 10 will be assigned to x, this 20 will be assigned to y, and this 30 will be assigned to z. At a time, you can assign multiple values to multiple variables. So, if at all you need any practical knowledge on these variables and then assigning multiple values and then global variables, I will just spend few minutes on that and then come back to the next slide. So this is the Python environment. We have a number of alternatives to run the Python. Whenever you install Python, Python can be executed in different ways. We can use Python IDE. You can use Python IDE. You can just directly download it from the internet, and you can even use Anaconda Navigator. This is the Anaconda Navigator, which includes number of frameworks. One of the framework that is present in that is the Spider. So this is the Spider. This is the Spider environment where we can type our Python program and we can see the output. And if at all you want to go with another environment, so directly you can go to the Google and there you can type download Python download for Windows, and you will be directed to this website. And here you can see this download Python link. And for your Windows, if your operating system is Windows, you can click over here. If your operating system is Linux, you can click over here. If your operating system is Macintosh, you can click over here and then click on Windows. Then you select whichever the version you want. You select whichever the version you want. Directly you can click on this and then download it. It takes 1 or 2 minutes and then you can install it. Once you install it, you can just type here using Python, and the Python IDE will be displayed. Click on it and then type your program over there. So right now I have deleted that Python IDE since I'm using this Spider. So Spider is very convenient than that Python IDE. The reason is Spider supports number of libraries. Automatically it provides number of libraries, number of modules and packages. We need not install them explicitly. Whereas if you go with the Python IDE, you have to install the number of modules on your own using the pip tool. So it is always better to go with Spider since it provides all the built-in modules. Now, the question is, we need not specify any data type. Based on the value What is this value?
Integer.
Integer. Based on the integer, based on this value, the type will be determined at the runtime. If you want to know the type of that variable, simply type n. So it gives you the type of the variable int. Similarly, I will take one more variable. M is equal to 12.3. Okay, print the value of M is equal to comma M I'm typing, and then just display the value of M is going to be displayed. I want to know what is the type of this M. What is the type of M?
Float.
So if you want to know that, you can type, you can use the method type, and inside the parenthesis you can use M and press enter. It gives you the type float. That way, Python is dynamically typed language. Python is a dynamically typed language, which means based on the value, the type of the variable is determined at runtime. So Python is dynamically typed language. Now, it also allows us to declare, for example, A, B, C here, something like this. For A, I am writing Python. For B, I am assigning 10, and for C, 12.34. Here if you observe, three values are assigned to three variables at a time. And if you want to print the value of A, the value of A is comma A. Just you can see the value being printed is Python. And if you want to print the value of print, the value of C is comma C if you type, so the value of C will be printed, which means we can assign multiple values to multiple variables at a time. And at this time, I would like to tell one more important concept called swapping. What is meant by swapping? For example, x comma y is equal to 10 comma 20. If I swap, initially the value of x will be 10, y will be 20. If I swap, x contains 20, y contains 10. How can we do that? So you can also do the same thing like this, x comma y. Initially, you can assign multiple values to the multiple variables like this. Later, you just type x comma y is equal to y comma x. And later, if you print the value of x is equal to comma x if you type, can you tell what will be the value of x now? And can you tell what will be the value of y now? But initially, what is the value of x? 10. What is the value of y? 20. But later on, using this statement, values are swapped and x takes 20, y takes 10. So swapping is very, very simple in Python. If you want to do the same thing in C language, if you remember, we have to take some temporary variable. First assign the x to temporary variable, then use x is equal to y, and then later y is equal to t. And this kind of setup we have to perform in case of swapping. You have to define one method like swap, and then write all these statements inside. At the end, values are going to be swapped. So in Python, you need not write all these things. The swapping is very, very simple because of this multiple assignment. Now I will go for for example, global variable. Sometimes you have defined a function. This is one function. Okay, this is one function, and you want to use the value x is equal to already defined is 10, and you want to use the same value over here. Okay, you want to use same value over here, and then print x is equal to 10, x is equal to x. So if you just type and then call the function fun, it prints the value 10 over here. So if you want to refer this variable inside the function, you have to use the keyword global. So if you use the global keyword before the variable name, it becomes global variable. And once you, if you do not mention this as global variable, for example, if I'm not using the keyword global here, if I'm not using the global here and trying to, I will assign some 10 here or else 20 here. And if I try to print the value of it, I will see 20. And later, if I print some value over here, x is equal to comma x, for this statement, it will print 10. For this statement, it will print 10. And for this statement, it will print 20. Just verify. So first, for this statement, it is printing 20. For this statement, it is printing 10. The reason is, inside the function, you have taken one variable, and this becomes local variable. Local variable will be always considered first than the global variable. When it comes to here, this is the main function. This is the main function. Once the function call is ended, the scope of this variable will be vanished. And then the scope of the global variable will be available, and hence it takes the value x. So this is the how we can refer. If at all you want to refer the same global variable, you just keep something like this, and then if at all you want to change any value here, x is equal to 30. If at all you want to change any value, somewhere some mistake has happened. Global, GLOBAL. Okay, so here I can even x is equal to 30 I can write, and later I can see initially what is the value of x. Here it will be 10. Since I am referring the global variable, inside the function, the global variable is changed. The changed value will be now available over here. It becomes 30. So that way, if you use global before the variable name, then it refers always the global variable. The change that you do inside the function will also reflect the original value or the global value. That global value will be available for the next statement. So that is how we can understand about the variables, global variables, and then assigning multiple values to the variables and so on. Coming to the next one, and built-in data types present in the Python. So these are the built-in data types present in the Python. These are the built-in data types present in the Python. So we have numerical data types, strings, and then Boolean. So if you look at the numerical data types again, in Python, the numerical data types contain integers, floating point numbers, and then complex numbers. So the strings that you write inside the double quotes or single quotes, it is called a string. It is a sequence of characters written either inside the single quotes or double quotes. And coming to the numerical, we have three numerical types here. One is integer, another one is floating point number, and the third one is complex number of the form a plus bi format. Boolean type, these types of variables can have either false or true. For example, a is equal to true or false. So if we want to know the type of the variable, we can use type function, which I have already shown you. Control statements. So we know that what is the use of the control flow statements. Say our program may contain number of lines. The program execution is being controlled by the control flow statements. The control statements are used to regulate. They are used to regulate the flow of execution of the program. Which statement has to execute first, then which statement need to be executed later, and so on. So these are controlled by the control flow statements. These are controlled by control flow statements. So under the control flow statements, we have three different control statements. One is selection statements, another one is loop statements, and third one is a jump statement. So under the selection statements, they're also called conditional statements, and then branching statements. Loop statements, they're also called iterative statements, and then jump statements are also called unconditional branching statements. Under the selection statements in Python, we have if elif, and then else statements. Under the loop statements, we have for and then while. Under the jump statements, we have break, continue, and pause. So here I will spend a little time on the control flow statements. Again, I will go back to the programs and let you know how they work. For example, so under the control flow statements, we have three different types. One is the selection statement, another one is loop, and the third one is jump. So why we use selection statements? Selection statements are used to select one option among the many alternatives. For example, you have in Python, if at all you want to read a number from the keyboard, we use input statement. There is a there is a function called input, enter n, and then this enter n will be displayed on the screen, and by the time you enter any number, that will be stored by default into string format, by default into string. But if you want to convert that into integer, you can use int function over here. So we use this input function. It is quite similar to the scanf statements in C language, or the next int or next function in the Java using the scanner statement. So to read the input from the user, we use input function, and then whatever you enter, that will be stored in the by default string format. But if you want that in the form of integer, you can use int function here, convert that into integer, and that will be stored in the variable n. Now I just want to test whether this n is even or odd. So you can just divide it by 2. If the remainder is equal to 0, you can say this is called f string. You can say n. Okay, n is even. Otherwise, print n is odd. So this way you can write. Okay, just compile it. It goes to this section. So that way, the selection statements it is used to select multiple. It is used to select only one statement among multiple statements, or only one choice among multiple choice. So at the same time, I will let you know one more example. Just look at this example. So we would like to test whether based on the score of the student, which grade he or she has got. So initially grade is empty, and now we are taking the score from the user. We are asking the user to enter the score here. So once the score is entered, that is going to be converted into integer, or you can, even if you want to convert that into float, you can type here float here. Nothing wrong in it. And that is going to be compared over here. It is passed to the function grade. This function is already defined here, and the score is going to be given as input argument here, and that score is going to be tested against this condition. If the score is greater than the 90 and less than or equal to 100, then it is A grade. If the score is greater than 80, which means 80 is less than score and score is less than 90, it is B grade. So that way, else its grade is F, and then we are going here based on the condition. If the condition is true, this portion will be executed, and then the control immediately comes to the last statement. Otherwise, if the condition is false, then control goes to the statement, and if it is true, it will be executed, and control skips the remaining. All these statements are skipped. Control will be given to this statement. So that way, The control statements are used to regulate the flow of execution. They are used to regulate the flow of execution of the program. Control statements are used to regulate the flow of execution of the program. So this is how the program execution is controlled by the if statement. So under the if we have if we elif, and at the end else. If above all the statements are wrong, at the end else will be executed. Sometimes you may interested with only one case. That is also possible. Then you can skip the remaining else, elif or else cases. So that way, selection statements are used here. This if selection statements are used to select only one among multiple.
వెనుక వెనుక నీ పేరు రావట్లేదు వెనుక నీ పేరు రాలేదండి
I am facing some disturbance, madam. Hello.
కావ్య అండి మా కావ్యాన అయ్యింది
Hello. 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 So control statements are used to regulate the flow of execution, and we have I have explained this if statement, if else, and then if elif also with this example grade program. I have shown this example also. And coming to if, sometimes you can write an if statement inside another if statement. If the condition is true, then this will be executed. Then if it is true, then this will be executed. Otherwise, it comes out of the, it comes otherwise it comes out of the loop, and then control will be given to this. So that way, it is sometimes required to write an if statement inside another if statement. An if statement inside another if statement. So if you do so, it is called nested if statements. So here I have given a small program to test whether the given year is leap year. So here, if the year needs to be leap year, it must be first divisible by 4. Every leap year is divisible by 4, and it must be divisible by 100, and it must be also divisible by 400. Then you can say it is leap year. Otherwise, if it is divisible by 100, else it is false. If it is divisible by 100, for example 2000, then you can say it is also leap year. Otherwise, false you can say. So this is how you can use nested if statements. Coming to the loop statements. So I will explain these loop statements with an example program. So in Python, we have two loop statements. One is for, another one is while. I'll let you know the syntax also, how we'll write the for loop and while loop. Mainly, the loops are used, you know very well why loops are used. The loops are used to repeatedly execute some block of statements. For example, I want to display something. Print Python. Python program. If I want to print this 10 times, what I can do? I can keep on copy and then paste it. At least for 6 times, if I want to print it, I can print the same thing here for 6 times just by doing it so. The same thing and just repeat it. So if you want to repeat the same thing there, you can use loops. So here same thing you want to repeat for more many number of times. In such a case, you can use loops. One of the loop that we can do with this is for loop. The syntax of the for loop will be like this: in, for in, And then here you can write range, how many number of times you want, 6 times. Then whatever the statement that you want to repeat those many number of times, just put that inside the loop and run it. The same output you can see here, same output. I'm just clearing, you can see the same output. You can see the same output. See, I'm just running it. Here I have written only one line. The same line is going to be executed for these many number of lines. So the loops are used to repeatedly execute a block of statement. Here I have written only one block of statement, one statement in the block. High level language. Python programming is a high level language. These two statements I want to execute for 6 times. So these two statements, which means what? This is the body, or this is the block, BLOCK block. What is meant by block? Anybody can answer? What is meant by block? Block is a sequence of statements that are to be executed. It's called a block. In C language, block is defined with curly braces, something like this. We will define the block like this, but in Python, we do not use any curly braces. Say all the lines, this is one block. Say all these lines must have the same indentation. The space before this line, the space before this line must be equal to the space before this line. So the block is defined with the space only. If I keep this line one space like this, then it will raise an error. If I keep this one like this, then no error will be raised. All the statements must have the same spacing. If at all it is a block, all the lines must have the same space. So this is how block is defined in Python, and it is different than in C and then Java languages. And this is how we can use for loop. The same thing you can also, for example, if you have a list of elements, L is equal to, you have a list of elements. The list contains something like this: 20, 30, 40, 50, and so on. Now I want to perform the sum of all these elements. To do that, I can use X in L. I can write where L is the sequence here, and now you can write total is equal to, initially I can take one more variable, total, initially set to 0, total plus X I can write. So for the first time, this X takes the first value 10, and that will be added to the total. Initially total is 0. It becomes what now? It becomes 10. Now next X takes the value 20, and that 20 will be added to the total, which is already 10 plus 20. It becomes 30. So 30 will be there in the total. Once this X takes the last value, then the loop is going to be terminated. So at the end, you can use print statement here to print the total. So we can see the total is something like that. So here the loop is used to repeatedly execute a statement or block of statement until some condition is satisfied. What is the condition here? Until it reaches to the last element. So that way we can use this loop. Similarly, we can do the same thing with while loop also. Instead of for, we can write while, and here I less than, how many number of elements are here? Len of L. Okay, and then you can just you can just take the plus L of I, and then I is equal to I plus 1. See, what is the initial value of I? I is equal to initially 0, total is equal to 0. Now I is less than len. You may get some doubt, what is len? Len is used to get the size of the list. You type len, it gives you 5. So I is less than 5. Initially total is equal to or block of statement until some condition is satisfied. Okay, until some condition is satisfied. These are used to execute a statement or block of statements until some condition is satisfied. So that is the main objective of the loop. I hope you have got. The loops are also called iterative statements. I have given some examples here. The same examples I have explained. Searching for an element. For example, if you have a list of elements and if you want to search for an element, whether the element is present in the list or not. So this is your list, and you are looking for this element 23. Whether this 23 is present in the list or not, we do not know. So in such a case, X in L, you take the first element. If X is equal to your ELE, X is equal to ELE, then we say that print element is present at position. How can we get that position? Comma, L of X dot index. Okay, so it gives the position also. So we have the element here. We have the element here ELG, and we are just comparing it. We take the first element and it is going to be compared. Else we can simply write element is not present. It's simply present, element is not present. So if you want to know the position, I will let you know how to get that position also. First let us see whether it is present or not. So element is not present. It is saying element is not. If the element is no, if the element is not present, it specifies like this. For example, if I write 20, then what? If the element is present, then I can break the process. See, first element is not matched, then the second element is matched, and I can stop the process. This is how we can search the element using the linear search. Once the element is present, we can stop the process. To stop the process, we can use the break statement. And you can even understand some other examples like prime or not. Okay, this is the example for prime or not. So for example, you have taken one number from the keyboard and you are testing whether it is a prime number or not. Can anybody tell me what is prime number? Hello? Hello?
Hello, sir.
Am I audible, madam?
Yeah, sir, audible.
Power has gone, madam. Okay, anyway, I'll cut. So, can anybody tell me what is prime number? Please respond. Okay, if a number has at most two factors, it is called prime number. To test for that, we are just verifying from the second number itself. If a number has any factor other than one in itself in between, then it is not a prime. This is the logic that we are using here. I am taking one number and then I am verifying all the numbers other than one and last number. In between, these are the numbers that I would like to test. And if you observe for a prime number, the factors, even if you observe the factors for 5, for example, or for the factors for 9, if you see 1, 3, and then 9 only. After that, and for 12 even 1, 2, 3, 4. After 4, 6. After that, what? You do not have any other factors except this 12 one. So I am just ignoring this one, and then also 12, and I am just verifying with the numbers in between. If a number has any factor in between, it is not a prime. So that is the logic we are using. So we are starting from 2, 3, 4, and then 6. How can we get this 6? If you divide this number by 2, you will get this 6. If you divide this number by 2, you will get that 6. So that way, and similarly, another example I will let you know. For example, for 15, then 15. So I need not verify 1 and then 15. In between, I will verify these numbers. If I have any other factor, if I have any other factor in between 1 and 15, absolutely it is not a prime. So if you take 7, what are the factors here? 1 and this 7 itself. So it does not contain any other factors. So if you take 2, you cannot divide this 7. You cannot, if you take 3, you cannot divide. If you take 4, you cannot divide. So hence, you will not have any other factors in between 1 and 7. So that is the logic why we have written 2 and why we have written n by 2 plus 1 here. So that is the reason behind it. So this to test the prime numbers also we can use the for loop like this. The same thing you can also do with the while loop also. Then coming to the jump statements. So if you want to stop the loop, you can use break statement. If you want to skip the current iteration, see, I will let you know how this break and this one for x in range. Okay, so for x in range 10 I am writing 1 comma 11 I am writing. I would like to print all the numbers. Print. Okay. X is equal to comma. I would like to print if x is equal to, I'm testing for 6. If x is equal to 6, then I have to stop the process. Okay. Otherwise, else I can print the number. X is equal to comma x, I can print the number. So in this program, you can observe all the numbers are being printed from 1 to 5. When the condition when the condition comes to x is equal to 6, since it is true, we are just breaking the loop. From here after, you will not see any other line being printed. And if you, instead of the break, if you use continue, instead of break, if you use continue, except 6, you will see all other numbers in the sequence except 6. See, after 5, you will have 7. You will not have 6. So whenever 6 is present, control will be given to the beginning of the loop, to this. That way, we can use the break statement to stop the loop, and continue to skip the current iteration. So if you want to stop the loop, use the break statement. If you want to skip the current iteration, use the continue statement. Okay, so that is the main objective of the break and continue. Now, sometimes, sometimes we do not, this pass, there is also another condition called pass. For example, while true, I will write while true. And print, I will write hello here. Okay, then I will write pass here. So if I write pass, the control will be given to the next statement. If I have some print here, so control will be simply given to the next statement. Control will be simply given to the next statement. Okay, so pass actually does nothing. Its main objective is to just pass the control to the next statement. Okay, now coming to the next one. So far we have discussed about 3 statements: selection statements, loop statements, and then jump statements. Under the jump, we have seen these 3 topics: break statement, continue statement, and then pass statement. So pass actually, it does nothing. It is used to just pass the control to the next statement. Now coming to the next one, data structures. Very interesting topic. There are 4 data structures present in the Python. These are mainly used in the various applications. So the first data structure is list. Then I will let you know step by step how list is created. A list is created using the square brackets. The elements are placed inside, separated by the comma like this, and this becomes a list. If you want to know what is it, you can just type here type and then pass L as an argument to it. It says it is list. So list is a collection of, what is list? List is a collection of ordered collection of items, where each item can be of any different type. There is no rule that all the elements must be of same type. List can contain any type. For example, here I have written 10, then I'm writing apple here, and then 34.5 I'm writing, and then I can even write 3 plus 4j, which is a complex number. Okay, so if you want to know the type of it says it is list. If you want to know all the elements are ordered, which means the first element will be stored at 0th position, the second element will be at 1, third element will be at 2, and the last element will be at n minus 1 position. So if you want to know the size of it, right? Len of L, it gives you the length. And if you write 0, it gives the first element. L of L of L of 3, it gives the last element. So list is a collection of different types of elements, ordered collection of different types of elements. So in general, it can contain different types, but for the sake of understanding, I am taking some integer numbers only for performing some operations. 3, 2, 1, 5, 10. So these are the elements I have taken, and now I would like to find the sum of all the elements. You can pass the function, you can use the function sum and pass the list name L as an argument to it. It returns the sum of all the elements. So initially I am just creating an empty list like this. This is called empty list. It does not contain any. This is called empty list. It does not contain any list. You can use for loop here. I in range. How many number of elements that you want? For example, maybe 5. Okay. So this loop repeats for 5 times. We can use append method of the list. There are number of predefined methods. I will let you know all the methods. There are number of methods. First method is append. So if you want to append an element to this list by reading it from the user, you can write enter element. If you do so, this loop repeats for 5 number of times, and all the elements are going to be placed inside. At the end, you can see the elements of the list or something like this. Yeah, if you type like this, you will see the number of elements. See, enter the element, maybe 3, 2, 1, 7, and then 4. Okay, all the elements are displayed. If you want if you want to sort all the elements, you can write L.sort sort. For example, if you observe here, there is all the elements are not in sorted order. So the list has one predefined method called sort. You can simply use this sort and type like this, see the elements. Now you can see all the elements being in the sorted order. If you want the element in the reverse order, now you can see all the elements being sorted in the reverse order. If you want to delete the last element, what is the last element here? This one. If you want to delete the last element, you can write POP method. So it automatically deletes the last element and your list contains only 7432. And if you want to push a new element, or if you want to insert a new element, you can use L.insert. You can use L.insert. And you can specify the position at which you would like to insert the element. Maybe for example 3, that is the position. What you want to insert? 10 you want to insert. So if you see at position number 3, this is 0 and this is 1 first position and this is the second position. In general, first position, second position, third position. At third position, I would like to this is 0th position, this is first position, third position, second position, and then this is the third position. At third position, I would like to insert this 10. So it is inserted like this. And if you want to remove, for example, if you want to remove a particular element, remove, there is a method called remove, and you can simply type remove, and that element will be removed from the list. And if you want to, for example, append one more element will be appended at the end, and I am just appending one more element too. See, list can contain even duplicate elements also. We are going to discuss next topic called set, which does not entertain duplicates. Now, if you want to know how many number of times a particular element has appeared in the list, L dot count, which means this two, how many number of times in the entire list appearing. So if you type L dot count, it gives you 2, which means at this position and at this position, it appeared only 2 times. If you type L dot count count of 10, for example, how many number of times it has appeared? Only 1 time. And if you want to know the index of, for example, index of element 3, it gives you 2. This is 0th position, 1, and then 2. The position of the element 3 is 2. So these are all the different methods that we have with the list, and all these methods are very useful. And coming to the another data structure, all these methods almost I have explained. We have discussed about the append method, we have discussed about insert, we have discussed about remove, we have discussed about pop, we have discussed about index, we have discussed about count, we have discussed about sort, and we have discussed about reverse also. And this is the only method that I have left. So this method is used for appending a list with another list. It is used to append a list with another list. So two lists can be joined with this extend method. So I will let you know that also. For example, you have here, I have another list L2, something like this, 50, 60. Okay. Now, if I want to extend using extend, and coming to the tuple is also like list. See, I can even remove the element. See, I can L dot remove remove. Let it be, for example, 2. If it is present, it will be removed. If I want to insert an element into the list at position number 2, I can do that also. So that at position number 0, 100 will be inserted. We can modify, once a list is created, we can modify, which means list is mutable. List is mutable, which means once a list is created, you can modify the list elements at any point of time. To the tuple, when it comes to the tuple, once a tuple is created, you cannot modify mutable. That is the only difference between tuple and a list. In Python, look at this one. In Python, it is similar to the list. The key difference is tuples are immutable, which means once they are created, they cannot be changed after the creation. Tuples created by placing the elements inside the parenthesis and separated by the comma. And this is how we create the tuple. And it contains only 2 methods. One is count, another one is index. And there are no other methods. No, like L dot insert, L dot pop, or to change these are the elements. If at all we want to insert a few more elements into it, maybe 10, 20, we want to insert into the tuple. Then how can we do that? There is a mechanism for that. First, you have to convert this into list, pass t as an argument to it. Now, your list contains the elements that are present in your tuple. Now you can append L dot append 10 first, and then L dot append 20. Okay, then you see 10 and 20 are being inserted. Later, again, you can write t is equal to tuple of L, you can write. Now your t contains all the elements. So this is another way, if at all you want to add any new elements to the tuple, but directly does not support. Indirectly, you have to first convert that into the corresponding list, and then add your required number of elements, then convert it into again tuple. That is the only way we have, if at all you want to change the elements of the tuple. Now, so look at the tuple. So tuple has only 2 methods, count and then index. Count returns the number of times a particular element is appearing. and index returns the position of the element. Note, if we want to insert element into the tuple, then we have to first convert that into the list, add elements to it, and convert it into the tuple again. In Python, dictionary is a mutable, unordered collection of items. Creating dictionary is simple by placing the items inside the curly braces separated by comma, with each item is being paired in the form of key and then value. This is the syntax of the dictionary. So together it is called an item. This is an item. This is an item. This is another item, and this is another item. So we have three items here, where each item is a key value pair, and key is separated by the column with value. And we have these many number of methods here, and this first one is called key. Here key is apple, here key is mango, and here key is orange. And 100, 150, 70, these are all values. If you want to have only the keys, then you have a method called keys. If you want to have only the values, you have a method called values. If you want to have the items together, then you have a method called items. I will let you know how it works. See here, I am just declaring a dictionary data structure here, and here it is, for example, apple. Its cost is 120 rupees, and then mango. Its cost is maybe 100, and then orange. Its cost is 50, and this is one dictionary. Now, if I want to print all the keys, I can write D.KEYS. Okay, it gives all the keys. Just look at it, gives all the keys: apple, mango, and orange. If you want to have the only values, then you can have that something like D.VALUES, and then you can see only values being printed as a list. You have to write values here. The values are printed. If you want both, along with printed as a tuple. Okay. So these are the some of the methods present, and if you want to know the value, for example, D.Get, the key is, for example, apple. So it gives you the value of that key. This get method is used to get the value for the given key. Similarly, you can also type here, instead of apple, you can write orange. So it gives the value of it. So this is how this get method is used, and then almost we have covered all the functions. Coming to so far, I have covered three data structures. One is list, second one is tuple, third one is dictionary, and now we are going to discuss about can be used to construct the data frame. See, this is the dictionary, and these are the names. Dictionary is constructed with three keys. One key is name, another key is age, another key is city. And these are the names, these are the ages, and then these are the cities where they are living. And this this data is now given as input to the data frame. Now you have constructed a data frame. Data frame appears to be like this. It contains rows and columns. So you can use the dictionary to construct a data frame. Once you construct a data frame, you can execute queries on that also. For example, let us use the same example here. I'm just instead of typing, I will just use the same data structure, the same data. So my dictionary contains this one. Now I have to import PANDAS as PD, And in the pandas, we have this pandas is another module that is used for creating the data frame and to work with the data frames. We can do a number of computations on the data frame. For example, I am going to create a data frame, PD dot. So there is a method, there is a constructor called data frame. To that, I will pass this data as an argument. Now, data frame is constructed. If at all you want to print the data frame, you can just use something like this, and you can see the data is being printed like this. Actually, we have used the dictionary, and now that dictionary is converted in the form of a data frame. If at all you want to, this is data frame. Okay, this is data frame. From this data frame, if you want to extract age, okay, and then mean, the mean age of that. If you see if you add all the ages and divide it by 4, the mean or average age will be like this. And similarly, if you want to extract from the data frame whose age, okay, whose age is greater than, whose age is greater than 33, whose age is greater than, for example, 33. If you want to have, just to do like this. See, we have only one record, whose age is greater than 33. From the entire table, if you write this query, we have only one record that satisfies this given condition. So you can observe here, Anna 34. This time it gives 2 records from the entire data frame. So we can use the dictionary to construct the data frame. On the data frame, later we can do some kind of operations like this for analysis. This is one application of the dictionary in data frame. Then coming to the last data structure called set. Hello? 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 Hello?
Hello, sir.
How long should I continue, madam?
Sir?
Up to what? Up to which time should I continue?
Kavi-
Hello?
Sir, 4:30, sir.
Up to 4:30.
Yeah, sir.
Okay, madam.
Sir, you need any break?
No, not required. Not required, madam.
Okay, sir.
I
Thank
will
you.
continue. Now, set, it is very, very useful. We use this set in the set theory. Normally, there are different perform union operation, and sometimes we perform intersection operation. And if this, for example, if I take one more small set, this is a subset of this set, and this let us name this as set S1, and this as S2. So S2 is a subset of S1, and this is, for example, let it be, for example, S3, and I can draw some. Observe, this portion is nothing but the intersection. This portion is, and this portion and this portion is part of the union operation. So when you perform union operation, you will have all the values. When you perform only intersection, you will have these values only. Okay, so these are the operations usually we perform on the sets. So I'll just whenever required, I will use this paint. Now, how to define the sets in Python? it is very easy to define the sets. Set is defined with curly braces and the elements are placed inside. Set is much similar to the list but does not contain duplicates. The nature of the set itself is it contains only unique elements. For example, at the time, for example, S1 to 10, 20, 30, 3, 4, 5. Okay, so I have two sets here. Now, if I print S1 here, S1, you will see, though I have given duplicates here, but the duplicates are not allowed in the set. Similarly, here also, in this set, let us assume that I have 10, 20, 10 here also. So even if I use S1, it does not entertain duplicates. S2, it does not entertain duplicates. Now, if I want to perform union of both, so I am creating one more set. S3 is equal to, okay, S1 dot union of S2. If I write, so my S3 contains all the elements that are present in both S1 and S2. Just observe, but without duplicates. So it contains all the elements 1, 2, 3, 4, 5, and then 10, 20, 30. If I perform, for example, S4, if I want to know section of S2, S1 dot intersection of S2, it gives only the common elements present in both the sets. So if you observe, in both the sets, 3, 4, 5, 3, 4, 5 are common. And you can also perform set difference. S5 is equal to S1 minus S2. You can even use minus operator. So it removes all the elements that are present in S2 from S1. It contains only elements that are S1. It's called set difference. And there is also another operation called symmetric set difference. S1 dot symmetric difference S2. In this symmetric difference, you will have all the elements but not common elements. You will have all the elements but not common elements. What are the common elements? 3, 4, 5 are common elements. Those except those common elements, you will have all the elements from both the sets. So these are the operations that we generally perform. And in, for example, in online shopping, if you want to, you have a data set and you want to, you have two customers and you have two customers transactions. If you want to know the common items that have been purchased by both customers, then you can arrange one set as the items purchased by one customer, and you can arrange one more set purchased by the another customer. And if you perform the intersection, you will have the common elements. If you know the common items, then you can improve your market. You can make a strategic decision that in future also these items can be requested by the users. So this is where this set plays vital role in predicting the things. So I have explained all these operations: union, intersection, difference, symmetric difference, and sometimes set and sub. Let us also observe. I have taken one more SS is equal to, for example, 1 comma 2. This is one set, and I would like to test whether this SS is a subset of subset is subset is SUB of S2. SS is subset of S1. If you type it says true. The reason is SS contains 1, 2, S1 contains 1, 2, 3, 4. So SS is a subset of S1. Similarly, if you want to test whether this S1 is superset of SS, it returns true. The reason is S1 is superset of SS. So that way, it gives us some confidence that if the items present in one set are also part of another set, then we can focus on the another set. Since it is having more number of items, this set gives us some insight that we can put more focus on the set or focus on those transactions in the data sets. So I have covered the data structures, all the data structures. I just give the summary of the data structures. We have 4 data structures here: list, tuple, dictionary, and set. List is a collection of ordered collection of different types of elements. It is mutable. Once you create, you can just change the list at any point of time, and these are the methods present. Tuple, it is much similar to the list, but it is immutable. Once created, you cannot modify the elements of the tuple. It contains only 2 methods, count and index. And dictionary, it is used to store the data, and that stored data can be passed as an argument to the data frame, and you can construct a table from which you can perform analysis of. Dictionary is constructed with the curly braces, and these are the methods available in the dictionary. And this is an example for creating a data frame with the dictionary, and way on which we can perform analysis also. We can give some queries also. And then coming to the set data structure, set is another unordered data structure, and it is much similar to the lists, but it does not entertain duplicates. Sets are mutable, but since they are unordered, they do not support indexing or slicing like lists or tuples. Sets create. So for I would like to test whether these 2 in S1 or not. If it returns true, which means what? The item 2 is in the set called membership operator. Membership operator. So I did not touch the different operators present in the lengthy topic. Just wherever it is required, there are different types of operators here. There are different types of other operators, arithmetic operators, and then comparison operators, then membership operators, then logical operators, and so these are the some of the operators. Under the arithmetic operators, we will have some plus, comma, minus, and then star, and so on. Okay, and under the comparison operators, we have less than, comma, greater than or equal to, and so on. And in the membership operators, we have in, comma, not in. And in the identity operators, we have is, comma, is not. And in the logical operators, we have and, comma, or. We have also called bitwise operators. In the bitwise operators, we have called and, or, not. Okay. Then exclusive or. These are all different operators. We have all these operators are also used in the expressions. So this in, if at all you want to test whether a particular item is a member of the set or not, you can use in operator. Operations on the sets also explained. Then coming to the functions, how we can define our own function, I will explain this topic. For example, in Python, we can define our own function called user-defined function. It starts with the keyword def, where def is a keyword, nothing but definition of the function. If at all, if I want to define the function with the name in, with the name add, which takes 2 arguments x, comma, y, and keep colon at the end, and inside this you can perform you take one more variable here, t is equal to x plus y, and later on you can print the sum is comma t you can write, and this is the function definition. This is called function definition. Function definition includes three things. It contains function header, and this is called these are the steps inside the function body. So this is called function header. Function header includes def keyword, function name, list of arguments, and then function body contains one or more statements that are to be executed in sequence. Once the function is defined, this is the main function. So far function is defined. Function definition merely cannot be executed on its own. It should be called explicitly. So this function add should be called explicitly with the equal number of parameters. For example, 10 comma 20. So the function is defined with two parameters. The same number of arguments need to be passed here, and then click over here. Now you can see the sum is 30 volt. So here, this is the function defined by the user. This is not the predefined function, and this is defined by me, and this is how I am calling the function. The function call contains function name and also the list of arguments. Okay. And coming to the, if you can also keep on defining number of functions and put that inside one module. For example, I can define one more function, x comma y, and t is equal to x minus y, and print, and just put this save as. I am just calling this as module, or else arith 1, arith new. I'm just making this as arith new, and label int input of enter a, and similarly you can read one more variable b, and this is b. Now you can call those methods. First method is a comma b, and the second method is sub a comma b. Now you run your program, save this and then run it. Test 6 for example. Now if you observe, so in the function definition itself we have some mistake. Just open it. Arith new. The arith new, at the time of subtraction I have used double quotes. You should not use like that. Now it is okay. Now you can go for test 6. This is the module that I have created. This is the program that I am using. From the this is my module which I have created that contains the functions that I have defined. Import star means import all the functions that are present in this module. So what are the methods present in that? These are the two methods present in that. I'm just the definition of these methods are defined in the arith module. Directly I'm importing the module and then passing the arguments, and you can see here it is asking me enter a 10, enter b 30. It is just giving the sum 40 and then subtraction result as minus 20. So you can understand how we can define our own functions and put functions inside one module, and you can access that module in your program, and you can access those functions, pass the arguments and get the work done. Very simple. So this is the overall concept. The next concept to discuss is types of arguments. Actually, for a function in Python, there are different ways to pass the argument. For example, I am defining one interest. The interest formula can be P into T into interest is stored in I, and the total principal amount Total principal amount is comma P. We can write. What is the function name? Simple interest. So I will use the same here and pass the arguments. So I would like to deposit 10,000 rupees for a period of 12 months and the rate of interest is 0.75. And now I would like to look at the interest that I will get. Something went wrong. PTR by 100, I have missed 100. Okay, so for a period of one year, I will get the interest 900 for 10,000, and then our 10,000 becomes 10,900. Now, here this is called function call. This is called function call. So in the function call, if you observe, I have passed the arguments, and these arguments, I have passed the arguments. See, I have passed the arguments, and these arguments, these are the arguments. These are the arguments. These arguments are assigned to the P and to the T and to the R in the order according to their position. According to their position, these are passed. So if you call a function and the arguments are assigned to the parameters of the function in the order, then that type of arguments are called positional arguments. They are called positional arguments. They are called positional arguments. See, whenever I call the function and the arguments in the function call, they are passed, they are assigned to the R sequence, or sometimes it may be arranged something like P comma R comma T. In such a case, if I put like this, if I put like for interest, what will be the interest? In this case, it will be no problem. If somebody arranges the arguments like this. Somebody arranged the arguments like this: R comma T comma 0.75. So 0.75 will be passed to the P. To that P, you are adding the interest. So I will just look at, I'll just show, for example, the arguments are passed in this order, 75, because by the time function is called, we do not know the order in which these arguments are arranged. So I will pass here and then the 10,000 rupees over here. Now you just observe what will be the result. What is the result you are getting at then? Interest is 900, but you have deposited 10,000, but you are getting at then only 9,000.75. What is that? It is just due to the order. So you have not passed the arguments. You have not passed the arguments as they are in the function definition. It is little confusing. In such a case, what we can do is, we can simply write R is equal to something like this. This is rate of interest, and then this is time, P is equal to, and this is your principal amount, P is equal. Inside this P is going to be assigned. So this P is going to be assigned to this P, and this R is going to, this kind of arrangements is called keyword arguments. This is arguments. This is called keyword arguments. First one I told you, positional arguments. Second one is keyword arguments. And there is also another way. For example, if you deposit money in the bank, if you open your account, at least you have to for some banks, and it must be for a period of 12 months, and the rate of interest will be 0.6 fixed. It is fixed. In such a case, you can call the you need not, by the time you open your account, you have deposited 5,000. At the end, you are getting 360 rupees plus. But if you want to deposit the maybe 20,000, something like this, comma, for a period of 24 months with the same rate of interest, you need, for calculating this interest, you need to have three items, P, T, R. Anyway, your 20,000 is going to be placed over here, and then 24 is going to be placed over here. For calculating this R is going to be considered. This kind of arguments are called default arguments. These are called default arguments. And there is also another concept called variable length arguments. For example, you have a function here. And this function takes two arguments, name comma L, preceded with L. When L is preceded with L, it is called variable length arguments. So here I can print the name T by score is comma AVG I can write. So I'm calling, this is the function call. I'm calling the function. How to call the function? My function name is fun, and these are the marks of the student Madhu, maybe, and this is secured by her in 5 subjects. In 5 subjects, she has got the marks like this. Now, if you write like this, see how many number of arguments I am passing here. Actually, here there are 2 arguments. First one is assigned to the name, and the remaining, this forms a list, and this list is going to be stored in L. On the L, we can perform operations, and you can see the average score like this. This is also, and you can even pass two arguments like this. So arguments are varying. You can even pass 78, 67. Arguments are passing. Arguments are varying. So when the arguments are even varying, this computes the result. This kind of arguments are called variable length arguments. So this is another key concept in the functions. Already how to create the modules and how to import, and we have to discuss about the NumPy and pandas, which are mainly used in machine learning, data science, image and signal processing, scientific computing. So these 2 modules are very powerful modules. I'll spend 5 to 10 minutes on these 2 modules to give some insights how to use these modules. So this NumPy, an array allows us to store the collection of multiple values in a single data structure. NumPy array is similar to the list, but with added benefits such as faster and more efficient. The difference between array and list is list contains different types of elements, whereas array contains the same type of elements. It contains only same type. List can contain types of elements. Clear? The list, the NumPy, that array, an array with 4 zeros, you can do so. If you want to create an array with range of 5 elements, so this is the array. And if you want to create an array with random numbers, this is the random numbers array. So NumPy module can be used to create arrays, and you can perform operations on the arrays also. So this is how a multi-dimensional array can be created. This is a list that supports 3 rows and 3 columns, which is nothing but 2D array. It is 2D. two-dimensional array. What is the definition of matrix? Matrix is a two-dimensional array. In fact, it contains rows and columns. How many rows and how many columns it contains? 3 rows and 3 columns. 3 rows and 3 columns is an argument to this array. And now we have constructed a matrix. And the matrix, we display this matrix like this. And if you want to know the dimension of this matrix, if you want to know the dimension of this matrix, and if you want to know the shape of this matrix, it is very easy to know all such things. I will just take here L is equal to 1 row, then 6, 7, 8, third row, close it. So here, and this L, I'm just creating an array here, np array of L, pass it as an argument to it. You see an array is constructed in the form of matrix. Now you can also construct one more array, np dot array. We have now two arrays, A and B. If you want to perform A plus B, now C contains both the elements. See how simple it is to perform matrix addition. And if you want to perform matrix multiplication, D is equal to A dot multiply D. MUL. Okay, A into B you can write, or else A you can see the multiplication like this. And if you want to multiply A with some scalar element, you can also do that by 2. And even you can perform scalar subtraction also. So this is how you can perform. If you want to transpose this A, dot T if you write, rows are converted into columns, columns are converted into rows. So these are matrices. And if you find the rank of a matrix, rank of matrix can be calculated with np dot linear algebra dot matrix dot lang. This can use to rank of this matrix. Very simple. Linear algebra. Here this is the function and pass and to it the rank. Here, if you want to know the size of it, one attribute 9 elements. Gives two-dimensional array. So these are the factors to know about so perform action. We have performed addition, performed the scalar multiplication. We have performed the multiplication, not multiplication. If you perform the multiplication, np dot Hello? వినపడుతుందా?
Audible, sir.
Okay, okay. So within 5 minutes I will close, madam.
Okay, sir. Okay.
So NumPy has some statistical functions like this, mean, median, which we have already covered. So for example, you have charging is also over. NP dot. Am I audible, madam? Hello?
Sir, please share your screen, sir.
Is it okay, madam?
Screen not visible, sir.
Is it okay now?
Okay, sir, it's visible.
Okay, for example, if we want to know the mean of the matrix A, then we can have np dot mean. And if you want to know the standard deviation of the matrix A, std of A, if you write, it gives you the standard deviation. And you can also know the minimum value of the matrix np dot max of the A using this function. So in the array we have the maximum value 8, and if you want to know the minimum value of the matrix, you can write min. These are all the some of the statistical methods present to perform some operations. Coming to the next one, pandas module. So this pandas module is very, very useful in particularly for data analysis, to analyze the data. So I will give you small examples how to do that. Earlier we have already used this how to construct a data frame from the dictionary, and then we have used this data. And coming to the what is the data frame? A data frame is a two-dimensional data structure like 2D dimensional array or table with rows and columns. So create a simple pandas data frame. We can create a simple pandas data frame like this, and we can see the records like this. df.loc. df.loc means loc0 means it displays the first record as it is shown here. If you want to display the records from 0 to 2, then you can observe here the records being displayed, records being 0 to 2 records from the data frame. So suppose if you have a comma separated values file, CSV file, if you have this CSV file also, you can pass from the CSV file also you can read the data, and you can do some sort of analysis. And to read the data from the CSV file, we have a function called read_CSV. And if you want to then you can construct the data frame. I will let you know with the example. So first I have to import pandas as PD, and now I am going to create the data frame PD dot read CSV function I will use, and to this I have to pass mark sheet. This file, I have already this file in the form of CSV in my computer. If you want to see that, this is the CSV file. So it contains ID, name, gender, and then section, science, English, history, maths. These are the subjects marks, and then the section. So based on these marks, we would like to do some sort of analysis. So there are almost 250 records here, 250 records, and let us see how we can work with this. And if you want to display df dot first five records, 5 rows or else. So just run it. The data that is present records. If you want to display the last 5 records. D.F.TAIL function allows you to display the last 5 records. Okay, and you can also do some sort of operations. For example, if you want to know the what is the average score in the science subject, so if you want to know the average of the science subject dot mean, if you write this mean function allows you to display. I will directly write this expression over here. See, the mean of the science subject is all the 250 students, average is 51 only. Similarly, if you write English, you can have the English mean. Similarly, you can also have the history like this. You also can write this query. This query enables you to just see. For example, if I want to have the students whose mean is above the mean of the science, so I can write science. I need to have the science students whose DF are. I want to have all the records of the students. I want to have all the records of the students whose science is greater than the mean of the science. If you do so, so it gives you almost 129 students are 129 students have got more than average marks. Out of 250, 129 students have got more than the average marks. And do the same thing for example, do the same thing for English. 125 students have got more than average marks. If you want to combine both, see, I am taking the students whose mean is greater than who are greater than their mean, and also the students whose history marks greater than their mean. If you do so, you have only 70 records. These are the students who have got the average in both the subjects, above average in both the subjects. So this kind of analysis we can do with the help of pandas module. This is very, very important module, and previous module, that NumPy and pandas, these are mainly used in the applications. If you want to know the description about the data, for example, your data frame name is DF, and if you want to know, if you want to describe, it gives DF.DESCRABE. Describe, it gives you the details of the entire data set. What is the mean, what is the standard deviation, what is the minimum value, what is the maximum value, and so on. If you want to know the information about the data frame, it gives what are the different columns we have and how many rows we have, are there any null values present, and so on. If you want to know the correlation between one column to another column, CORR, this CORR function is present, it gives you the correlation. Wherever the correlation is 1, which means those two columns are correlated well. If the correlation, something like if you see 0.02, the column ID and age are not well correlated. And similarly, if you look at if you look at somewhere, whose in general, if the correlation is 0.9, those two columns have some meaningful relationship. So if you are able to extract that meaningful relationship, if something is changing, another thing is also changing. That way we can perform some logistic regression, linear regression kind of prediction techniques we can apply on those columns. So This is about the some of the information related to the pandas. And now you also can draw the plots. You also can draw the plots using the plot function of the data frame. For example, you have your data frame, its name is DF, just write plot, it gives you the diagram. Like this. If you want to have only the plot for the science subject, dot plot you write. It gives you the plot for only science subject. Similarly, you can have the plot for the maths. So this is the overall graph of the students, how they have got 250 students, how they have got the marks. So this is another concept, use it for representing the graphical representations. And with this, I would like to conclude. Principal Dr. Kalyani Madam, Damacharla Sakkubayamma, Government Degree College for Women. I thank you for giving me time slot for sharing some insights with the students, particularly in the area of applications of Python. And the coordinator, Sarla Madam, thank you for approaching me and giving this opportunity to share my knowledge with you. And all other staff members, students who patiently listen to my topics, I really thank you for your patience. And the technical staff also who supported to carry out this webinar. I thank each and everyone for making this possible. So from my side, I'm going to conclude. Thank you very much for every one of you for giving me this opportunity once again.
Thank you so much, sir. Wow. Thank you so much, sir. We hope this webinar is useful to our students, sir. So as you explained, these Python concepts so very clearly with suitable examples. So the all mathematical related functions and NumPy, SciPy, libraries, etc., sir. So hopefully this session is very useful to us, sir.
Thank you very much, madam.
So now we'll conclude our topic with vote of thanks. So I'm honored to propose the formal vote of thanks. First of all, I thank the Commissioner of Collegiate Education for their support in organization of various programs. I express my sincere gratitude to our beloved principal, Dr. Kalyani ma'am, for granting us permission to organize the program. I am very much grateful to Dr.